Hello everyone, in this video we're going to review apcalculus BC topic Euler's method and logistic root. Alright, before we're going to dive into questions, let's review some concepts behind this topic. First, we're going to talk about the Euler's method. Alright, so we're going to use point slope form of equation of tangent line y equals m times s minus s1 plus y1, right? Where m equals dy over ds and s minus s1 is the step sign. Sometimes we're going to name step sign as h or delta s. y1 is the value of y the first term. Now, next one, we're going to talk about the logistic growth. In apcalculus, the exponential growth model was derived from the fact that the rate of change of a variable is directly proportional to the value of y. When using the differential equation dy over ds equals k times y, and its general solution y equals c times e raised to the kt, you may notice that the exponential growth is unlimited. However, when describing a population that often exceeds an upper limit L, past which growth cannot occur, this upper limit L is called the carrying capacity. It represents the maximum population y of t that can be sustained as time t increases. A model that depicts this type of growth is called a logistic differential equation. dy over dt equals k times y times 1 minus y over L, where k and L are positive constants. The logistic differential equation of the form dy over dt equals k times y times 1 minus y over L results in a solution of the form y equals L over 1 plus b times e raised to the negative k times t. Alright, so we have the formula logistic differential equation form is going to be this one, and logistic growth equation form is going to be this one. In either form, L represents the carrying capacity right here, L right here, and L right here should be the same, or upper limit of the logistic growth equation, which is the maximum. Alright, a logistic growth curve increases the fastest when the curve reaches half its carrying capacity L. Now let's move on to question 1. Let y equals fx be the solution to the differential equation dy over ds equals x plus y with the initial condition f of 1 equals 2. What is the approximation for f of 2? If Euler's method is used starting at s squared 1 with step size h equals 0.5, right? Now we just get the table. Alright, initial condition is right here, s equals 1, y equals 2. So we just place 1 and 2 over here, right? Now the step size h equals 0.5 and the final value of s should be 2, right? So you just keep adding 0.5 to s value until you get 2, right? So 1 right here, 1.5 right here, and 2 right here. We stop right here, right? Because we need to calculate f of 2, right? Now, dy over ds equals this formula right here, s plus y, right? So you just add 1, 2, it's going to be 3, right? Now, you need to find the equation of the tangent line, right? So we know that y minus y1 equals m times s minus s1, right? Or y equals m times s minus s1 plus y1, right? So I have y equals m equals 3 right here, right? this one is the slope times s minus s1 is right here, and plus y1 is going to be right here, right? Now we substitute 1.5 for s into this equation to find the new y value right here, right? So we have 3 times 1.5 subtract 1 is going to be 0.5, right? Plus 2. So it's going to be 3.5, right? So right here I just put 3.5. Now the new slope is 1.5 plus 3.5 is going to be 5, right? Equation of the tangent line y equals 5 times s minus s1 is 1.5 plus y1 is going to be 3.5, right? Now substitute 2 for s over here. We have 5 times 2 minus 1.5 is going to be 0.5, right? Plus 3.5, right? So it could be 2.5 plus 3.5, it could be 6. We put 6 over here. The answer must be C. Now let's move on to question 2. Question 2 is similar to question 1, right? So I'm going to leave this one for you to practice. The answer is D. Now let's move on to question 3. Alright, question 3 similar to question 1 and 2. We just get the table. The initial condition is right here, x equals 0, y equals 1, right? And look at the step side right here. 2 steps of equal sign starting from s was 0 and then ending as negative 0.6, right? So this guy must be negative 0.3 and this guy should be negative 0.6, right? Now dy over dx, we're going to use the formula right here, right? S plus 2y, right? So it could be 2. Equation of the tangent lines y equals, the slope is going to be 2 times s minus s1 is going to be 0, right? Plus y1, which is 1, right? Substitute negative 0.3 for s over here. So we have 2 times negative 0.3 is going to be negative 0.6 plus 1 is going to be 0.4, right? Put 0.4 over here, right? Now dy over dx is going to be s plus 2y, right? So it's going to be negative 0.3 plus 0.8, right? So it's going to be 0.5 right here, right? So y equals 0.5 times s minus negative 0.3, which means at 0.3, right? Plus 0.4. Substitute negative 0.6 right here. So we have negative 0.3 times 0.5 is going to be negative 0.15 plus 0.4 is going to be 0.25, right? So we put 0.25 over here. This one is the final answer. The answer must be D. Now let's move on to question 4. Assume that f and f prime have the values given in the table. Use Euler's method with 2 equal steps to approximate the value of f of 4.4, right? So 4.4 is the final values right here, right? Remember, we have f of s equals the slope times s minus s1 plus f of s1, right? F of 4.2 equals the slope is negative 0.5 right here, right? Times s minus s1, but s1 equals 4, right? Plus f of s1 actually 2 right here, right? So f of 4.2, substitute 4.2 by s over here, we have negative 0.5 times 0.2 plus 2, right? So it could be 1.9, right? Now f of 4.4 is going to be, the slope is right here, right? Negative 0.3 times s minus s1 right here 4.2 plus the values right here, right? 1.9. So it could be negative 0.3 times. Substitute 4.4 for s over here, we have 0.2 plus 1.9, right? So it's going to be 1.84. The answer must be C. Now let's move on to question 5. Question 5 similar to question 1, 2, 3, 4, right? So I'm going to leave this one for you to practice. The answer is C. Now let's move on to question 6. Consider the differential equation dy over dx equals ax squared plus 4 over y, where a is a constant. Let y equals fx be the particular solution to the differential equation with initial condition f of 0 equals 2. Euler's method starting from s equals 0 with step size of 2 is used to approximate f of 4. Steps from this approximation shown in the table above. What is the value of A? Now we have the equation of the tangent line is going to be f of s equals the slope times s minus s1 plus f of s1, right? Now we have f of s equals, we need to calculate f of 4, right? So we need to use the previous s and y values right here, right? So the slope is given by this formula, right? So we have a times s squared, s equals 2 right here, so it could be 4, right? Plus 4 divided by the y value actually sits right here, times s minus s1, which means 2, plus f of s1, which means 6, right? Now f of 4 actually 10 right here, right? And it's going to be substitute for s over here. We have 4a plus 4 divided by 6 times 2, right? Plus 6, right? So it's going to be 4a plus 4 divided by 3 plus 6 equals 10, right? It's going to be 4a plus 4 plus 18 subtract 30 equals 0, right? So 4a equals 8. Then a equals 2, right? The answer is B. Now let's move on to question 7. Let f be the function satisfying f prime of s equals negative 3s times f of s for all real numbers s with f of 1 equals 4, right? This one is the initial condition, right? Question B. Use Euler's method starting at s equals 1 with step size 0.5 to approximate f of 2, right? So we just get the table. Alright, the initial condition is right here, s equals 1, y equals 4, right? And you know that the step size is 0.5, right? And it's going to be ending at 2, right? So we have 1.5 and we stop at 2, right? Now we need to find the slope of the equation. So we have the slope is given by this formula, right? Negative 3 times s times f of s, right? So negative 3 times 1 is going to be negative 3 times 4 is going to be negative 12, right? So equation of the tangent line is going to be y equals the slope negative 12 times s minus s1, which means 1, plus y1, which means 4, right? So we substitute 1.5 for s over here. We have negative 12 times 1.5 subtract 1 is going to be 0.5, right? Plus 4. So it's going to be negative 2. We put negative 2 over here, right? Now, new dy over dx is negative 3 times 1.5 is going to be negative 4.5 times negative 2 is going to be 9, right? So y equals 9 times s minus 1.5 subtract 2, right? So it's going to be 9 times s equals 2 right here. Subtract 1.5, it's going to be 0.5 minus 2, right? So it could be 2.5, right? We put 2.5 right here. This one is the final answer. Now question 8, similar to question 7. I'm going to leave this one for you to practice, right? The answer is negative 23/4. Now question D. Let y equals g of x be another solution to the differential equation with initial condition g of 0 equals k, where k is a constant. Euler's method starting at x equals 0 with step size 1 gives the approximation g of 1 equals 0. Find the value of k. We're going to sketch the table. Alright, initial condition is x equals 0, y equals k. Now the y over the x, we're going to use this formula, right? So it's going to be 2k plus 1. Now equation of the tangent lines, y equals 2k plus 1, right? Times x minus 0 plus y is going to be k, right? Now we start at x equals 0, step size 1, right? So the final value should be this guy right here. Substitute 1 for x over here, right? So we have 2k plus 1 times 1 minus 0 plus k. And this guy actually 0 right here, right? So we just solve the equation, right? So we have 2k plus 1 plus k equals 0, right? So we have 2k plus k equal be 3k equals negative 1, right? So k equals negative 1 over 3. This one is the final answer. Now question 9. This question is similar to the previous question, right? We have two step size, right? Starting as equals negative 1, so we have negative 1 over here, and then we're going to end as 0, right? So it could be negative 0.5 and 0 right here, right? I'm going to leave this one for you to practice. The answer is 17/4. Now let's move on to question 10. The function f is twice differentiable for x greater than 0 with f of 1 equals 15, f the program of 1 equals 20. Values of f prime, the derivative of f given for selected values of s in the table above. Question A. Write an equation for the line tangent to the graph of f as x equals 1. Use this line to approximate f of 1.4, right? So we have f of s equals m times s minus s1 plus f of s1, right? S equals 1, so we have the slope, which is f prime of 1, right? But f prime of 1 is 8, right? Times s minus 1, right? Plus f of 1. F of 1 is 15 right here. So we need to calculate f of 1.4. It's going to be 8 times 1.4 subtract 1 plus 15, right? So it could be 8 times 0.4 plus 15, right? 8 times 0.4 it could be 3.2 plus 15 it could be 18.2. Now question B. Use a midpoint riemann sum with two subintervals of equal length and values from the table to approximate the interval right here. Use the approximation for this guy to estimate the value of f of 1.4. So the interval from 1 to 1.4 f prime of x ds using the midpoint formula. So we look at this one right here, 1 and 1.4 right here. We have the interval right here, 0.2, right? And this guy, 0.2, right? The midpoint is right here, right? this is the S value, and the height is 10 and 13 right here, right? So we have length times width, right? The length actually f prime of 1.1 plus the width 0.2, right? Plus f prime of 1.3 times 0.2, right? Now f prime of 1.5 actually 10 times 0.2 plus f prime of 1.3 actually 13 times 0.2, and it's going to be 4.6, right? Now to calculate f of 1.4, we're going to use the fundamental theorem of calculus, right? So f of 1.4 equals the initial value is going to be f of 1 right here, right? Plus the integral from 1 to 1.4 f prime of s ds, right? So it could be 15 plus 4.6 is going to be 19.6. Now question C. Use Euler's method starting at s squared 1 with two steps of equal sign to approximate f of 1.4. Now we're going to sketch the table. Now we start at s squared 1, right? The y value is 15 right here, right? We have two steps of equal sign. We end at s equal 1.4, right? So 1.4 is right here. This guy must be 1.2. Now to find the slope, we need to calculate f prime of 1, right? So look at the table. F prime of 1 is 8 right here. And the equation of the tangent line, it could be f of s equals 8 times s minus 1 plus 15, right? Substitute 1.2 for s, so it's going to be 8 times 0.2, it's going to be 1.6 plus 15, it could be 16.6, right? So we put 16.6 over here. Now dy over ds, so we need to calculate f prime of 1.2. It's going to be right here equals 12, right? So we have f of s equals the slope equals 12 times s minus 1.2 plus 16.6. So we substitute 1.4 for s over here, right? So we have 12 times 0.2 plus 16.6, right? 19. Now let's move on to question D. Write the second degree Taylor polynomial for f about s squared 1. Alright, now we know that the Taylor polynomial expansion is given by this formula. Now since the question wants you to find the second degree only, so we stop right here, right? So we have t2 of s when s equals 1. We have f of 1, right? But f of 1 equals 15 right here, right? So we have 15 plus f prime of 1. F prime of 1 is 8 right here. Times s minus 1 plus f double prime of 1. It's going to be 20 right here. 20 divided by 2, it could be 10 times s minus 1 squared, right? So it's going to be 15 plus 8 times 1.4 subtract 1 is going to be 0.4 plus 10 times 0.4 squared, right? So it's going to be 19.8. Now let's move on to question 11. The number of moves in a national park is modeled by the function m that satisfies the logistic differential equation dm over dt equals 0.6 m times 1 minus m over 200, where t is the time in years, and m of 0 equals 50. what is the limit of m of t when t approaches infinity. So when t approaches infinity, this guy approaches L, which is carrying capacity. Carrying capacity is right here, 200. Right? The answer must be B. Now let's move on to question 12. Which of the following differential equations for a population P could model the logistic growth shown in the figure above? Alright, so observe that this figure has the carrying capacity 200, right? Now remember, we have the differential equation of a logistic growth model given by dy over dt equals k times y times 1 minus y over L, where L is the carrying capacity. Now look at the answer choice right here. Y in this situation is P, right? So I just replace y with P, right? So I have dP over dt equals k times P times 1 minus P over L, right? Now I'm going to expand this one, so it could be dP over dt equals kP minus k over L times P squared, right? So this formula, we're going to come up with a conclusion. A correct logistic equation must have a positive linear terms Kp, right? This guy positive. A negative quadratic term, this one is negative right here, right? And level off at the carrying capacity L right here, right? So we look at the answer choice right here. We need to eliminate C, D, and E because they all have the positive quadratic term, right? Now for the first one, we need to factor P out. So we have 0.2 minus 0.001 P, right? So we're going to set this one equal to 0, right? So we have 0.2 minus 0.001 P. So it's going to be P equals 200, right? Which is the maximum value right here, right? So the answer is A. Now look at answer choice B. We factor P out, right? So we only end up with 0.1 minus 0.001 P. Set this one equals 0. So P equals 100, which is not the right one, right? So answer choice B is wrong. Now let's move on to question 13. Let K be a positive constant. Which of the following is a logistic differential equation? We know that the logistic differential equation is given by the formula dy over dt equals k times y times 1 minus y divided by L, right? So we look at the answer choice right here, only E correct, right? So this problem very simple, you just recognize the logistic differential equation, right? Now let's move on to question 14. The number of fish in a lake is modeled by the function p that satisfies the differential equation dp over dt equals 0.003 p times 1000 minus p, where t is the time in years. Which of the following could be the graph of y equals p of t, right? So basically, you just recognize the logistic growth differential equation. That's it, right? So actually, answer choice is A. Consider the logistic differential equation dy over dt equals y over 8 times 6 minus y. Let y equals f of t be the particular solution to the differential equation with f of 0 equals 8. Question A. A slope field for differential equations given below. Sketch the possible solution curves through the point 3, 2, and 0, 8. So 3, 2 is going to be right here, right? And 0, 8 is going to be right here, right? So we just follow the flow, right? So it could be something like this. Now let's move on to question B. Use Euler's method starting at t equals 0 with two steps of equal sign to approximate f of 1, right? So we're going to sketch the table. Alright, so we're going to start with t equals 0, right? So we put 0 right here. F of 0 equals 8, right? So we have y equals 8, right? dy over dt, we're going to use the formula right here. So we substitute 8 for y over here. We have -2, right? The equation of the tangent line is going to be y equals the slope -2 times t minus 0, right? Plus y is going to be 8, right? Now we're going to stop at 1. We have two steps of equal sign. So this guy should be 0.5 and this guy should be 1, right? Substitute 0.5 for t over here. So we have -2 times 0.5 is going to be -1 plus 8 is going to be 7, right? Now put 7 over here. So dy over dt is going to be 7 over 8 times 6 minus 7 is going to be -7 over 8, right? So we have y equals -7 over 8 times t minus 0.5, right? Plus 7. Substitute 1 for t over here, so we have -7 over 8 times 0.5 plus 7, right? So it could be 105 over 16. This one is the final answer. 16. A population is modeled by a function p that satisfies the logistic differential equation dp over dt equals p over 5 times 1 minus p over 12. Question A. If p of 0 equals 3, what is limit of p of t when t approaches infinity? Alright, so look at this one. This guy actually dy over dt equals k times y times 1 minus y over L, right? We just match this guy up, so we have the carrying capacity is 12, which is the maximum value, right? Limit of this one when t approaches infinity is always equals carrying capacity, which is the maximum value, right? So it could be 12. This guy is still 12, right? Question B. If p of 0 equals 3, for what value of p is the population growing the fastest? Remember, the population is growing the fastest when p is half the carrying capacity. Now let's move on to question 17. A certain rumor spreads through a community at the rate dy over dt equals 2y times 1 minus y, where y is the proportion of the population that has heard the rumor at time t. Question A. What proportion of the population has heard the rumor when it's spreading the fastest? Alright, so we need to find the maximum of this function, right? So basically, I just let the function f of y equals dy over dt, and it's going to be 2y, I'm going to distribute this one, minus 2y squared, right? I need to find the first derivative of this one, f prime of y equals 2 minus 4y, right? Now I'm going to let this one equals 0, right? It's the same thing as 2 minus 4y equals 0, and then y equals 1/2, right? So the proportion is 1/2. Now question B. If at time t equals 0, 10% of people have heard the rumor, find y as a function of t. So we have dy over dt is given by 2y times 1 minus y, right? Now we're going to separate the variables, so we have dy over y times 1 minus y equals 2 dt, right? Now we're going to take n time derivative both sides. Now we're going to use fraction the competition for the left hand side. So we're going to end up with antiderivative of 1 over y plus 1 over 1 minus y altogether dy, right? Equals antiderivative of 2 dt. So it's going to be antiderivative of 1 over y dy. Now for the second one right here, I'm going to replace dy with d of 1 minus y so that I can apply the formula antiderivative of du over u is going to be ln absolute value of u plus c, right? So it's going to be negative antiderivative of d of 1 minus y over 1 minus y, right? Because when I take the derivative of this one, it's going to be negative dy. So I have negative side right here, it becomes positive, so thing doesn't change at all, right? So keep that in mind. Equals antiderivative of 2 dt, right? So it's going to be ln absolute value of y, right? Minus ln absolute value of 1 minus y equals 2t plus c. Now we're going to use the logarithmic property to condense this one. So it could be ln of y divided by 1 minus y, right? Equals 2t plus c, right? Now I'm going to exponentiate both sides. So this guy turns out to be y divided by 1 minus y equals e to the 2t times e to the c. But e to the c is a constant, so I name this one as a value of k, right? So I'm going to end up with k times e to the 2t, right? I'm going to use the initial condition right here. At t equals 0, 10% of the people heard the rumor, right? Which means 0.1 equals y, right? So I'm going to end up with 0.1 divided by 1 minus 0.1 equals k times e to the 2 times 0, right? So k equals 0.1 divided by 0.9. It's going to be 1 over 9, right? So we're going to substitute 1 over 9 for k back over here, right? So we're going to end up with y over 1 minus y equals 1 over 9 e to the 2t. Now we're going to cross multiply, so it could be 9y equals e to the 2t minus y times e to the 2t, right? So it's going to be 9 plus e to the 2t times y equals e to the 2t, right? I divide both sides by this guy, so y equals e to the 2t divided by 9 plus e to the 2t. This one is the final answer, right? Now let's move on to question C. At what time t is the rumor spreading the fastest? Alright, so we go back over here. The rumor spreading the fastest when y equals 1/2 right here, right? So we're going to substitute 1/2 of y into this guy right here to solve for t, right? So we have 1 over 2 over 1 minus 1 over 2 equals 1 over 9 times e to the 2t, right? So it's going to be 1 over 2 over 1 over 2 equals 1 over 9 times e to the 2t, right? So it's going to be e to the 2t. This guy equals 1, right? Multiply both sides by 9, it's going to be 9, right? Take natural log both sides, so it's going to be 2t equals ln 9, right? So t equals ln 9 divided by 2. But ln 9 is going to be ln 3 squared over 2. We can bring 2 to the front. So it's going to be 2 ln 3 over 2. It's going to be ln 3. This one is the final answer. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
Tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.